Hey folks, how are you doing? I'm looking at tired. I'm looking at this from my perspective. It's teaching for a long time, and this is learning for a long time. And it takes brain power, doesn't it? Are you? You probably have permission to eat a little bit more, okay? Because I'm eating more. I'm burning calories. I'm burning a lot more calories. Doing this, I find myself hungry. I've been eating before I start lecturing. I get hungry in the middle of lecture, and I'm hungry after lecture. So, all right. So we'll just do about 35 minutes of this, so that we get our toes dipped into the second chapter. All right. These are unsaturated hydrocarbons. We've just studied saturated hydrocarbons. These are unsaturated. And there are three different groups in here. Alkenes, we will concentrate on these. But we'll mention these two. You'll see aromatics poking up. We'll mention the others so that you kind of know, but they have some form of unsaturation. They either have, so the alkenes have carbon-carbon double bonds in them. So instead of the carbons being attached to each other with just a single bond, there's a double bond. And alkynes have a triple bond. And then the aromatics, we'll get to at the end of this chapter, they have double bonds in them, and they're alternating double bonds in a ring structure. So we'll get to that. The simplest alkene. Now, if you're going to have a carbon-carbon double bond, you can't do that with methane. Well, it has one carbon. All right? So there's no way for carbon to double bond with the same atom of carbon. So in the alkenes and the alkynes, the simplest ones start out with 2 carbons in them. And then they go up from there. 3, 4, 5, 6, 7, 8, 9, 10, however many carbons. Okay, now let's just take a look real quickly here here's chapter 10, saturated hydrocarbon. Carbons are surrounded by single bonds. You got ethane, 2 carbons with 6 hydrogens around them. The simplest alkene, ethene. Carbon-carbon double bond. Now, because there's 2 bonds there, we only need 2 hydrogens to satisfy the 4 bonds that carbon wants to have. So a double bond does count as 2 bonds. And then 2 hydrogen bonds, and you got your 1, 2, 3, 4 bonds around that carbon. 1, 2, 3, 4 bonds around that carbon. That's ethene. So ENE means there's a double bond in the molecule. Ethyne. YNE means there's a triple bond. So 1, 2, 3 bonds, there's only 1 hydrogen. 1, 2, 3 bonds and 1 hydrogen. And you have ethyne. I think I was starting there. So here's ethene. Almost got it. Here's ethene. Here's ethane. Ethene. Ethine. Okay, now you'll notice some things about this. This is a 3-dimensional molecule. You know, this has got shape to it. It strikes out a certain volume. But you put in a double bond between the 2 carbons, and now you've got a planar molecule. It's flat. It's flat right there. All those atoms are in the same plane. Yeah, it's got some shape to it, it's changed the bond angles. We now have 120 degree bond angles here. 120, 240, 360. So to get around this carbon is 360 degrees. That's a full circle. A full circle has 360 degrees in it. Well, we've cut it into 3 parts. So 360 divided by 3 is 120 degree bond angles around a double bond. And this doesn't rotate. I told you this rotates. The single bonds you can freely rotate. You can get into different conformations around that single bond. There's nothing really constraining this from getting into different conformations. But around this double bond there is. This is constrained. It doesn't rotate. There's no way to get that hydrogen over to there. Even though there is a hydrogen over there already, you can't get this hydrogen over there by rotation. It's fixed. Here's ethine. Right there, there's a model of it. It is linear. Those 4 atoms are in a straight line. Hydrogen, carbon, carbon, hydrogen, 4 atoms in a line. So if I look at this carbon and I go over to here, that's halfway around the circle, 180 degrees. And I go over to here, there's the other halfway around. So the bond angle around this carbon is 180 degree bond angles. That's ethine. We'll look a little bit more at condensed formulas. What you're going to see in alkenes, even when you draw a condensed formula, you are going to put the double bond in there. The rest of the molecule you don't need to do any bonds, but where there is a double bond, we're going to actually draw it even in a condensed formula. All right, this gets into the bond angles, what I just said, 109.5 degree bond angles, 120 degree bond angles, 180 degree bond angles. All right, now we still have an alkane over here, 1, 2, 3, 4, 5, that's pentane. It says it right there, so this is pentane. 1, 2, 3, 4, 5. And you're going to say, oh, that's part alkene and part alkane. No, it's an alkene. This is an alkene. One double bond makes it an alkene. Okay? That's pentene. That molecule will behave differently from this molecule because of that functional group right there. When we get the reactions, you'll see it very clearly. This molecule is going to react differently than that molecule. So this is pentene. It's got 5 carbons. It's got a double bond. So we're going to change the suffix from ane to ene. Pentene. And this is pentyne. Yeah, okay. Actually, this is 1 pentene. And this is 1 pentyne. We'll get into the numbering here in a minute. But this double bond starts on carbon number 1. 1, 2, 3, 4, 5. So that, triple bond. I think I said double bond. That triple bond, YNE triple bond, begins on carbon number 1. So it's 1 pentyne. Let's get that one. Let's put 3 more carbons on that one. I love these molecules. Some of you are in the 1107 lab, some of you are not. I think tomorrow I may bring a little sampler of the experiment that the 1107 students are going to be doing, not tomorrow, but Thursday. They're going to be making a bunch of different model molecules with these kits, drawing them, comparing them. It's going to be mostly chapter 10 and 11 kind of stuff. If anybody wanted to join us 8 o'clock Thursday morning, you're welcome to. If you wanted to do these down in the tutoring lab has these kits.
At 9, right? We agreed.
9. Right. Thank you. 9 Thursday morning. We usually meet at 8, but we're going to do it at 9 on Thursday morning. So 9. Yeah. Good. So you're welcome. Should be plenty of room in there. And I might print off a few extra of those things in case you wanted to do it, in case you wanted to make more of these models and just really get familiar with this stuff. So there's one pentyne. All right, got a triple bond, and then it starts looking like an alkane over here. We go back to 109-degree bond angles. It rotates fine right there. Rotates around that bond, but it doesn't rotate around this one. Oh, did I skip past the slide? Okay, what are these like? These are nonpolar. We still have carbon-carbon bonds. We still have carbon-hydrogen bonds. What makes a bond polar or nonpolar has to do with the difference in electronegativities between the atoms. And these two carbons are identical. They have the exact same electronegativity, so they share the electrons equally. And it makes for kind of a nonpolar, no separation of charge. The electrons are equally everywhere, and you don't get any charge build up anywhere. So these are also nonpolar. They're not soluble in water. They are soluble in alkanes. Alkanes are nonpolar. Alkenes are nonpolar. They dissolve one another. They will mix. So if you had propine in your gasoline, it would just be dissolved in there. You wouldn't see it separate out at all. Yeah, you're starting to see a little bit of structural or condensed formulas for 1-butene, CH2, a double bond CH, CH2, CH3. There's your, we'll draw some of these out and maybe we'll see that a little bit clearer. Okay, IUPAC names. Yeah, we'll get into a little bit of the naming of these molecules. All right, so we already know eth means 2, prop means 3. Well, we're going to carry that over here. Ethene is a 2-carbon molecule with a double bond in it. Propene is a 3-carbon molecule with a double bond in it. Propine, ethyne, propine. IUPAC names. Number from the end that will give the first carbon of the multiple bond the lower number. What you got to do here, you know, what's rule number 1? Okay, find the longest chain. Now what you're going to need to add to that as you go into alkenes is find the longest chain that contains the double bond. The double bond has to be in that longest chain. Even if you can find a longer chain, but you didn't go through the double bond, you didn't get the longest chain. You got the wrong longest chain. It's got to include the double bond. All right, so that's what we're going to see here. So let's look at this top one. What is the longest chain? Seven? Okay, so it could be this 7 right here. We could have started there, and we would have still gotten 7. But no matter which one we started on, we would have had a leftover ethyl group, right? So we have an ethyl group here, and we have a methyl group here. So let's go ahead and name this one. The next thing you need to keep in mind. Now we got to figure out what's going to be carbon number 1. Now look, we got a methyl group here on that carbon. 1 carbon in from this end. But that would have us starting that double bond in carbon number 4, right? If I start counting over here, if I said this was carbon number 1, this was number 2, now that double bond is starting on carbon number 3. So that is carbon number 1. Even though there is a substituent closer to the other end, this double bond is going to be dictating the parent name of this molecule. It's going to have an ENE ending in it. So we're going to give precedence to get to that double bond the soonest. All right, so this is carbon number 1. So you said it's got 7, so that's going to be hept. Hept what? Hept? Louder. Ene. Okay. Usually when you say it softly, I don't know if you're confident about your answer. And you really, ene, then I know you know your answer, okay? It's like when people sing. You know, you don't, come on, a little bit louder. I'm not going to sing for you. Okay, heptene, and it's going to be 3 heptene. Okay, now this 3 is telling us where that ene is. That's what that 3's for. And so, what else do we need on there? A what? Methyl. What else do we need on there? The ethyl. We don't have that in there yet. So what is that? 3 ethyl, 2 methyl, 3 heptene. Yes.
Okay, so how is it 2 methyl? Maybe like 6 methyl?
Oh, you're right. Whoa. So what is it?
6.
Told you teaching this long is tough. 6. Right. Thank you. Okay? You need to question things. When you have questions, question them. It may be wrong. That's 6 methyl. That's a 6 methyl. Once we decide what carbon number 1 is, it determines every other carbon in the chain. That better? Were some of you confused when I put a 2 on there? Okay. Unravel that. Get unconfused. We don't want people to be confused. Okay, you see that? And here's the other thing to see. We learned IUPAC naming rules in Chapter 10, and I'm telling you, that just doesn't have to do with Chapter 10. We're going to use those rules as we go into other chapters. We're going to have to adjust them a little bit. You can see we adjusted them here. We don't go off of the end closest to the first substituent. We get to the double bond. It's the same thing we would do with a triple bond. You're going to get to the triple bond as soon as possible. Lowest number. Even though we could get a lower number for that methyl group, we need the lowest number for that functionality. And then make sure you pick up everything else that isn't in the parent name. That methyl group isn't in here. that ethyl group isn't in here. So we now got it covered. 3 ethyl, 6 methyl, 3 heptene. And we need that number. If you left that number out, I wouldn't know whether the double bond was there. You know, there's 3 places where that double bond could be and still be a heptene. Okay, let's name this one. How many carbons? 6. So hex. Hex what? Hex. Ein.
That's how you say it.
Ein, like German. It's probably where it does come from. The Germans really paved the way in a lot of this organic chemistry. So, okay, now here we go. We got a little conundrum here. 1, 2, 3, or 1, 2, 3. So what's going to be 1? Over here. Why? Not because we need, we got a substituent. It's not going to matter whether we start here in terms of that bond. It's still going to be on the 3rd carbon. But when here be 1, 2, 3. So it's going to be 3 hex sign no matter which end I start numbering it on. But if I start numbering here, I get a lower number for the bromo group. So it's 2 bromo, 3 hexine. And we want the lower numbers. If you can ever name something with a lower set of numbers for most things, then that's usually almost always is the more correct way of doing it. All right, there's your answers. Okay, name that molecule. What's the longest chain? 6? 6. 6 is the longest chain.
So you don't put a number in front of it.
No, you will put a number in front of it. Yeah, 1. See, you know it's 1 because you're seeing it. But if I just gave you the name has to be able to help me draw that molecule. You see? So if you left the 1 off, I wouldn't know where to put the double bond. All right? So don't think, oh, I can see it's 1. Yeah, you can see it's 1, but you got to think, what if all I had was the name? Would I be able to draw this molecule from its name? Okay, so this is carbon number 1. How many of you have the name? The whole name? And nothing but the name? So help you God. All right. Keep at it. Let's get the parent name. It's hexene. And it's 1 hexene. All right, and then what else? Two ethyl. Okay, now I'll tell you what, since this is a dimethyl, you can see why you need this right here to distinguish this 1 from this L. We can see that that's a number and that's a letter. Whenever you see a prefix, if it's di, then there got to be 2 numbers. 2 numbers. It's going to be 4, 4, dimethyl. Even if the methyls are on the same carbon, you don't just put down 1, 4. Because I don't know whether they are both on the 4th carbon or you forgot to tell me where the other one is. Okay? So when you use a prefix, if you use the prefix tetra, there should be 4 numbers in front of it. 1, 1, 2, 2, tetra, chloro, something or other. Where are all those chloros? There are 4 chloros on the molecule. Okay. All right, this slide just quickly points out that you can have a molecule that has 2 double bonds in it. And what do you do there? Well, you take the prefix di and you put it in front of the ene. So this is 2, 4 dash hexadiene. Diene. There's 2 double bonds. Pentadiene. Heptadiene. There's 3-methyl 1,4-cyclohexadiene. So there's hexadiene. So you can have more than 1 double bond in there. Cycloalkenes. Well, before we look at a complicated one, let's just... All right, you're going to have you're going to probably want to have a little series of 3x5 cards of 6 carbons in a ring. There's going to be a whole family of molecules, probably 7 or 8 of these. That one you already know. On the previous slide, you just saw cyclohexadiene, but there's cyclohexene. Let's draw the structural formula of that. All right, now so let me go around here. This has got to have 2 hydrogens on it. This has to have 2 hydrogens on it. This down here has to have 2 hydrogens on it. This has to have 2 hydrogens on it. What about these 2 carbons that are left here? How many hydrogens are on those? 1. See, there's already 3 bonds around them. All right? 1, 2, 3 bonds already around that carbon. We only need 1 hydrogen. 1, 2, 3 bonds around that carbon. We only need 1 hydrogen. So cyclohexene will have 2 less hydrogens than cyclohexane. All right, so let's see what they're trying to tell us here. Here's cyclohexene. This is cyclohexene. 6 carbons. Here's our double bond. We've got a methyl group here. We've got a chloro group here. And so the question comes up, do I start here and go 1, 2, 3, 4, 5? Or do I start here and go 1, 2, 3, 4, 5, 6? So if I started here and counted around to this substituent, I would go all the way to a 6-methyl. 1, 2, 3, 4, a 4-chloro 6-methyl. But if I started here and went 1, 2, 3, 3-methyl, 4, 5, 5-chloro, I get lower numbers. So this is the correct name of that molecule, 5-chloro 3-methyl cyclohexene. Which direction will get you the lower numbers for the substituents? Yes?
Oh, okay. The double bond is just one, so you don't pray, right? For the double.
Yeah, right. You're going to start, and you wouldn't go this way. You wouldn't go 1, 2, 3, 4, 5 like this because you didn't go through the double bond. Whenever you start on 1, you have to go through to 2. You have to go in that direction through the double bond. So this is 1, that's 2. 1, 2. And yeah, so you don't need the 1 because there's, wherever the double bond is where 1 is going to start. So that's naming cycloalkenes. I'm not going to worry too much about this one. Naming haloalkenes. We did this one already. Okay, cis and trans isomers. This is this is really important, but I think we need 15-20 minutes to get this point across. What are cis and trans isomers? So that's where we'll pick up on chapter 11. Let's take a